Hello, in this lesson I want you to perform compositions of functions and I want you to apply compositions of functions. Your vocabulary is composition of functions. A composition of function just means I'm going to take a function of another function. So for example, if I look at here, function f takes me from a to b. So in other words, 1 goes to 1, 2 goes to 3, 3 goes to 1, and 4 goes to 2. Now, function g takes me from b to c. So I'm going to take 1 goes to 2, 2 goes to 3, and 3 goes to 1, and 4 goes to 2. Now, if I take a composition of the functions of g of f, that's what the little circle means, of f, I'm going to go from A to C. I'm going to cut out the middle part, but notice I still end up in the same spot. So if I look at A, I went from 1 to 1, then takes me to 2. So I'm going from 1 to 2. I went from 2 to 3 to 1, so 2 to 1. I went from 3 to 1 to 2, so 3 takes me to 2. And 4 goes to 2, which goes to 3, so 4 takes me to 3. When we do have a composition of functions, we work from the inside out. So first off, I'm going to find, it says on example 1, I'm going to find the composition of functions of f of g of 3. So the first thing we're going to do, let's find g of 3. So g of 3 is 2 times 3 plus 1, which is 7. So then I'm going to find f of 7. So then f is x squared minus 4, so I'll have 7 squared minus 4, which gives me 49 minus 4. So 45 is the composition of f of g of 3. Now you're going to find out it's not commutative. If we do it backwards, I want to find g of f of 3. So on example 2, so I'm going to start on example 2. First I'm going to find f of 3. And so f is x squared minus 4, or 3 squared minus 4. And 3 squared minus 4 is 9 minus 4, which is 5. Then I'm going to find g of 5. Well, g is 2x plus 1, so I'm going to say 2 times 5 plus 1, or 11. So g of f of 3 equals 11. And then f of g of 3, the composition of functions of f of g of 3, that's 45. Now let's take a look at a list here. I want to find f of g of x, and then I want to find g of f of x if it exists. And then state the domain and range for each combined function. So I'm going to start here with f, composition of f of g of x. So I start with g. G takes me from 7 to 0. So my range is my domain of f, and so my 0 takes me to negative 1. So in other words, I'm going to have 7 goes to negative 1. Then I'll look at my next one. Negative 1 takes me to 7, and 7 takes me to 7, so I have negative 1, 7. Let's look at a third ordered pair. 4 takes me to 9, and 9 takes me to 4, so 4 takes me to 4. And then the last one, 8 takes me to 2, and 2 takes me to 6, so it's 8, 6. And there we have it. Now let's do g of f of x. So I'll start with f this time. So on f, I start with 2, which takes me to 6. But notice there's no 6 in my domain for g, so that point doesn't exist in this composition. Let's take a look at the next one. 9 takes me to 4, and 4 takes me to 9, so then I'm going to have 9, 9. Third ordered pair. I'm going to start with 7, which takes me to 7. And then 7 takes me to 0, so I'll have 7, 0 here. And then my last ordered pair, 0 takes me to -1, and -1 takes me to 7, so I'll have 0, 7. And there's your composition of functions.